single plate breaks due to asbestos conductor. So when a single plate breaks due to atmospheric convection and tension force applied upwards, some portion of the plate will sink downwards, forming cracks. Formation of so when a single formation of the lift is formed when a single plate breaks down due to atmospheric convection. So atmospheric convection around 10 and doesn't provide upon some portion of the plate. So when a single plate breaks down due to atmospheric convection and pressure force applied upwards, some portion of the plate will sink. Hi Rishabh, I'm studying now. I'm conducting a live study session in a more systematic way. So we'll be doing quiz at 11:30. Okay. Performing it, the what will happen and the blocks might. Uh, the blocks when the portion of the blocks when down has will melt. So while forming if the fault will happen and the blocks might slide down, forming if the portion of the blocks when down in the atmosphere will melt. The lighter material uh, the lighter material will melt first and form magma. If it is lighter new magma, the lighter magma will tend to come out. So while forming it, the fall will happen and the blocks might slide down, forming a rift. So while forming it, the fall might. So while forming it, the fall will happen and the blocks might slide down, forming it. The portion of the blocks when down in the atmosphere will melt. So what will happen while forming rift? The fall will happen, okay, and the blocks might slide down, forming a rift. So okay, the fall the portion of the blocks went down in the atmosphere will melt. Of course, the lighter material will melt first and form magma, which will create lighter new magma. Okay, the lighter magma will tend to come out. So the lighter magma will tend to come out. This partial melted part will create lighter magma, and the lighter magma will tend to rise first. Okay. So the lighter magma will solidify more vertically, as it will not be able to flow. is gently solidified. Denser magma with horizontally solidified, high density with low easily, low viscosity. So it's going to have a low viscosity, solidifies slower. This is a dense magma. The magma which comes from the deep inside will be denser, of course. The magma which is coming from the top will be lighter. In magma, the magma which is coming from the top will be lighter. In magma, more the silica, the more the acidic is the magma. Lesser the silica content, less acidic. So more silica content will be more acidic, and lesser the silica content, less acidic is the magma. So in the magma, more the silica content, more acidic. Okay, higher the will be the silica content in the magma, the more acidic will be the magma, and the magma, more the silica, the more the acidic is the magma, and lesser the silica content, the less acidic is the magma. So more the silica content, more acidic is the magma, lesser the silica content. So in magma, more the silica, okay, more the silica, more acidic, less acidic. Sigma concept. If the silica is more than 60% become acidic. If the silica is less than 50% becomes basic. Okay. So if the silica content silica content is more than 60%, it becomes acidic. If the silica content is less than 50%, becomes basic. The lighter magma will be acidic, so more silica content. The lighter magma will be acidic, and dense magma will be more basic, of course. So lighter magma more acidic, so ज़्यादा छिड़कता है, मतलब spreads and will rise up vertically, right? Horizontally spreading. The upper magma will have lighter water concept, so lighter magma will be exclusive and denser will be less amount. So the lighter magma will be exclusive, of course. More silica content. The magma more the silica, the more the acidic, of course. So the lighter magma will be acidic, the denser will be more basic. So lighter magma will have more silica content, so it will be more acidic, and it will have more water content. The upper magma will have higher water concept, so a lighter magma will be more explosive and denser magma down. Okay, two causes of explosiveness. First is water content, right? So lighter magma will have more water content and solidifies fast, acidic because of silica, high silica content, high silica content. So what is the characteristics of lighter magma? So the lighter magma will have so lighter magma water content, more silica content, will be acidic, will solidify fast. The acidic more silica content, done. Denser magma will be darker and lighter magma as it contains silica will be lighter. Okay. Silica is used to make glass. Okay. Going back to convection, the denser magma should create denser crust. Okay, so it will create oceanic crust. So the denser magma should create denser crust. That's why it will create oceanic crust. The denser magma should create denser crust called the oceanic crust. The lighter magma will create the continental crust. Okay, so the characteristics of denser magma, lighter magma. Denser magma flows more horizontally. Hi Sanjul, you can like, share, subscribe the channel. This is a live study session. Session number 2 is going right now using Pomodoro technique. So the denser magma should create denser crust for the ocean crust and the lighter magma. Okay, done. आवर चेंजिंग. ओके, तो आप रिवाइज कर सकते हो. अभी अभी मेरा सेशन चलेगा 6 घंटा और अभी 12 बजे तक मेरा सेशन चलेगा, फिर 12 से 2 बजे रात तक चलेगा. यू कैन रिवाइज विथ मी इफ यू वांट. यू कैन सिट फॉर स्टडी. Thank you, Sanjul. Okay, so just 8 minutes is left. Let's do the session seriously. Oh no, some issue is there. Okay, some technical glitch is there. We'll see it. So you can do the session. Have to look at this. I have to look at my laptop. Just 8 minutes. Okay, just 8 minutes are left. After 8 minutes I will be solving the issues of my laptop. Let me see what's the issue. I'll take a 5 minutes break and at that time I'll be solving. So okay, when peaks are formed, magma erupts. Sometime it will also lead to atmospheric changes and rain will happen and the depression may form. So okay, so when peaks are formed, magma erupts. Okay, so when peaks are formed, magma it will also lead to atmospheric. Okay, that I know. Rain will happen and in the depression may form the lakes because of okay due to rift valleys and all. So lighter magma, what all it forms? So what are lighter magma forms? Fault, rift valleys, block mountains, of course. Then volcanic and active peaks and lakes. Okay, so block mountains से ये सब बनेगा. Volcanic active peak, volcanic active peak. So what are lighter magma is when it is formed? So then there is a fault during the time of the formation of the rift valley. There is a fault in the block mountain. Fault mountain, block mountain, because they were moved due to the movement of the blocks. They were moved due to the movement of the blocks. called rift valleys, block mountains, because they are moved due to the movement of the blocks of volcanoes actively made. So in Africa, तो सिर्फ बंद ही हो गया लैपटॉप से, कुछ टच हो गया बंद. Valleys. So it's your valleys. So it is your valleys, Mount Kilimanjaro. So Mount Kilimanjaro, Mount Kenya, Lake Victoria. Okay. So in Africa, it continues. Africa. Rift valleys, East Rift Valley in Africa, right? Mount Kilimanjaro, Mount Kenya, and Lake Victoria. So the example of the rift valleys. Mount Kilimanjaro, Mount Kenya, and Lake Victoria. Mount Kilimanjaro, Eastern Valley, Mount Kilimanjaro, Mount Kenya, Lake Victoria, for example. The valleys are like a block mountain divergence, as some part of the block will move and go into atmosphere, and where it will melt and lighter magma will come out. Lighter magma have high silica content, high water content, rise vertically. Okay, so it's more explosive actually because of high water content and all. Okay, so in India, where the rift valleys. So in India, we have the rift valleys of the Vindhya and Satpura. Rift valleys of Vindhya and Satpura, the block mountain. So block mountain African region. So now you know how the block mountains are formed due to continental divergence. Some part of the block will move down. Continental divergence, some part of the block will move down, form lighter magma that will rise up, and then other it will lead to the formation of the block mountains. Okay, so already defined with the formation of block mountain. Examples from in Africa, in East African Rift Valley, East Rift Valley, Kilimanjaro, Kenya, KK, and Lake Victoria. Lake Victoria was also formed due to formation of block water because of the depression created. That depression water gets collected, right? Yes. So that's why there is a formation of Lake Victoria. And Vindhya and Satpura range are the block mountains. Okay. Now see African physical map. I have to see the map. Okay. What is there at the two ends of the ridge? So what is there at the two ends of the ridge? That is a mid-oceanic ridge in the ocean crust. So two opposite ends of the ridge. Darker magma leads to formation of okay, yeah, we know darker magma will lead to the formation of oceanic crust, and lighter magma will lead to the formation of the continental crust. So after the rift will be filled with oceanic water. Okay, denser magma will lead to the formation of oceanic crust, of course, and continent will separate, creating an elongated sea. So after the rift will be filled with the oceanic water. After the rift has taken place, okay? Denser magma will lead to the formation of the oceanic crust. Okay, and continent will be separated. Then there is a separation of the continent, creating an elongated sea. So we have the Red Sea. We have the Red Sea. We have the Persian Gulf region and all. Yes, and continent will separate, creating an elongated sea. Long sea will be formed. Example, we know Red Sea, Persian Gulf and all. Yeah. Over a long period, the continental plate will diverge, and in between them there will be a large ocean floor, because denser magma will always form oceanic crust, lighter magma will form the continental crust. So when there is a continental divergence, that can lead to the formation of the rift valleys, block mountain, and if the denser magma rises up, then it can lead to the formation of oceanic crust, and lighter magma will lead to the formation of rift valleys and the block mountains. Okay, I'm almost done. Break. I'm taking break now. Enjoy the break, guys. Rock Mountains, and East African Rift Valley, East African Rift Valley, Mount Kilimanjaro, What is there are the two ends of the ridge. Darker magma leads to a formation of oceanic crust. That we know darker magma, the heavier magma will always lead to a formation of oceanic crust, because oceanic crust is heavier than the continental crust. That's why it's below the, it's in the ocean, it's below the continental crust. After the rift will be filled with oceanic water. Okay, denser magma will lead to the formation of oceanic crust, and continent will separate, creating an elongated sea. Creating an elongated sea. Long sea will be formed. Example, Red Sea. Over a long period, the continental plate will diverge, and between them there will be large ocean flow formed due to heavier magma. On the center there will be mid-oceanic ridge. Below there will be convection. For example, we know the Atlantic spreading theory, Atlantic expanding theory, the formation of the mid-oceanic ridge and how the Atlantic Ocean is expanding. Because continuous formation of oceanic flow is happening. Because in Atlantic we have the mid-oceanic ridges, that leads to divergence and formation of oceanic crust, and the Pacific Ocean is shrinking because there in the trenches these diverse continental crust are submerging, they are subsidizing. So this is the issue. So done. And now we are moving to continental ocean divergence. Is it possible continental crust and oceanic crust divergence? No, it's not possible. In case of divergence only, so when there is a divergence, there only oceanic crust will be formed. It won't form. There will be no continental oceanic divergence. On both sides, only oceanic crust is formed, because magma is always basaltic. That means heavier magma, basaltic. In case of divergence, only oceanic crust will be formed. It won't form continental. Divergence. On both sides, only oceanic crust is formed, because magma is always basaltic. In case of divergence, only oceanic oceanic divergence, oceanic plate divergence will be formed. It won't. There will be no continental divergence. No oceanic continental divergence is not possible. On both sides, only oceanic crust is formed, because magma is always basaltic. Divergence story is done. So what all divergent from oceanic crust? Lighter magma will lead to the formation of the rift valleys, because the block will separate and get inside the asthenosphere. That will lead to the formation of the lighter magma that can form the rift valleys, like Satpura Vindhya, East African Rift Valley, and the lakes. And due to depression, lake like Victoria will be formed. And then we have the oceanic divergence that leads to the formation of the oceanic crust. So already done. Now moving towards convergence. What all will be formed? Convergence of the plate boundaries. So oceanic plate convergence, that will lead to the formation of island. Okay. So denser oceanic plate will go down inside the magma. First, whenever two oceanic crust will come in contact with each other, or they will converge, it is a denser oceanic plate that will move inside the asthenosphere, and again it will melt there. Again it will lead to the formation of the magma due to asthenospheric convection, and the lighter magma will come up, and it will lead to the formation of island. So denser oceanic plate will go down inside the magma. Yeah, I know. If the plate has to go up, it will go up against the effect of the gravity, of course. So they go down. Yeah, it has to go in under the effect of the gravity. So they go down under the influence of the gravity and compression. The denser plate goes down when they compress each other. ओशन वाटर प्लेट बना दो, एटमॉस्फेरिक कन्वेक्शन चल रहा है. So they go down under the influence of the gravity and compression. The plate will not be single pure compound. It is a mixture of many compounds. So a lighter part of the plate will melt first to form the magma. So this is the oceanic plate, and then the denser plate will go down, the one that is denser in the atmosphere. In the atmospheric convection magma आएगा, and then ऊपर lighter वाला magma सबसे ऊपर आएगा, and this will lead and will then solidify and it will lead to the formation of islands. The lighter part of the plate will melt fast and form magma. The magma formed due to partial melting of the plate will form lighter magma. Okay, so when there is a partial melting of the plate, the oceanic plate, it will form lighter magma. Because the lighter magma will try to rise up, of course. Then a lighter magma is it has more silica content, more water content, more explosive, right? Thus it will try to crack the other plate and come out. It will form seamounts, islands. This will form islands. For seamounts, it can form seamounts and then islands. Oh, that's what we call as seamounts. That trenches, mid-ocean seamount, gayouts and all. Okay. This will form island. This island will have volcanic peak which will be active. Hawaiian island. Okay. Yes. Done. So I have to finish this video. Now moving to an example like Aleutian Trench in the Pacific Ocean. This is a place where the two plates can converge and lead to the formation of islands. Yes. So this is a very interesting. That's why in Pacific Ocean we have lots of islands, because there the two plates they converge, and the heavier plate it subsidizes, and then it melts, and due to atmospheric convection the lighter magma rises up and it leads to the formation of seamount and island, because trenches is there in the Pacific Ocean only. So that's why we see a formation of lots of island in the Pacific Ocean. While in Atlantic Ocean we have the mid-oceanic ridges. So due to mid-oceanic ridges, there the plate diverge from each other, and when the plates diverge, it leads to breakdown of the continents and formation of oceanic crust, and that's why we say that Atlantic Ocean is expanding and Pacific Ocean is shrinking. So Aleutian Trench in Pacific Ocean island will always be towards non-subducting plate. So this is a very interesting point. So island will never be on the side of the plate that is denser, that is subducted, that has went down under the effect of gravity. It will always be there towards non-subducting plate. Trench will always be there at the subducting plate, right? So island non-subducting and trenches will always be there at the subducting plate and the plate which is going inside, because that's the function of the trench. It's very deep, so it goes inside. So example of some of the trenches. Look at the trenches. Okay, subducting plate and island and non-subducting. Japan Trench, Iso-Bonian Trench, Mariana Trench, Middle Place Trench. So Japan Trench, Iso-Bonian Trench, Mariana Trench, Papua New Guinea Island, that is Bougainvillea Trench, Narmadic Trench, the Pacific Ocean is subducting, right? So ocean convergence and island. So convergence of the oceanic plate lead to the formation of island. Hi Ronnie, I'm good. So you don't come when I take break. You come when I start my study. So I'm not able to reply you. I reply after 30 minutes. Can you see the timer? So Japan Trench, Izubonin Trench, Mariana Trench. Narmatic Trench and Pacific Ocean. Okay, now this is done for sure. I'll reply you after half an hour. Okay, just see the timer. I'll reply you after half an hour. I'll do that. This is my pattern I'm following right now. So ocean convergence and islands to form. In Pacific Ocean, there are multiple minor plates, thus forming the chain of islands. So there are major plates and minor plates. There are multiple minor plates, uncountable. Major plates, 7: North America, South America, African plate, Eurasian plate, Pacific plate, Indo-Australian plate. Now moving to our oceanic continental convergence. So what oceanic continental convergence will form? It will form volcanic mountains, active mountains, what we call is active mountains. So oceanic crust convergence will form island, and continental crust and oceanic crust convergence will form volcanic active mountains. For the volcano to be there in the mountain, there has to a plate which is going inside the asthenosphere, subsidizing inside the asthenosphere, the denser plate. Now let's see. Now there is a continental oceanic plate. There is a continental oceanic plate, continental plate. Okay, the plate is subsidizing, and here the mountains is formed on the continental crust region, because always volcanic active mountains are formed on the plate which is not subsidizing. Convection, atmospheric convection, melting of the magma, atmospheric movement of the magma, rising up, break the crust, form volcanoes, keep on solidifying, form mountains, and keep on solidifying, and then it becomes volcano active mountain. Okay, now island is made up of lighter magma or the continental crust. Yes. So this is the concept of island. So island is made up of lighter magma because it's a continental crust. Oceanic crust will be made up of denser magma. And island and continents, all this will be made up of lighter magma. So when two oceanic crusts compress, only subduction happens. So when two oceanic crusts will compress, an island will be formed. And when a continental plate is at the convergent boundary first, then continental plate starts getting compressed, and if the other plate is oceanic, it will start subducting. Now this that I know. When compress is formed in continental plate, it will create endogenetic force. Okay. So when compress is formed in the continental plate, it will create endogenetic force, that is warping and folding, forming fold mountains. So of course, when there is a convergence of the oceanic plate and continental plate, it will lead to the formation of fold mountain, because block mountain are formed due to the divergence, oceanic plate divergence. volcano active block mountains. And one more way that the and through one more way that the block mountain is formed is that continental convergence, like the Mount Everest. So that's why the Mount Everest is not a vol not an active peak. We do not have active volcano in the Mount Everest because it is formed due to continental convergence. There is no subduction of the plate. There is just force applied between two plates that leads to the rising of the landform, and leads to the formation of the mountains. So if the other plate is oceanic, it will start subducting. When compress is formed in continental plate, it will create endogenic force. Continental plate. Okay. Also warping and folding, forming fold mountains. The right compress. Okay. Now example of the fold mountains. Let's see. In South America, that is Andes Mountain is a fold mountain. Andes Mountain, North America. So North America, Rocky Mountain, South America, Andes, and Appalachian Mountain as well. Mount St. Helens, along the it has been formed along the continental margins. It did erupted in 1981. There's a important, there's a very interesting story on Mount St. Helens. How did it erupted and what happened? So Mount St. Helens erupted in 1981. USA, volcanic eruption in cold mountain massive eruption, Mount Etna, Mount Vesuvius, Mount Sicily in Italy, Mount Sicily in Italy. So the magma will be acidic, that is lighter, high silica content ammonia. So cold mountain examples: Andes Mountain, Rocky Mountain, Mount St. Helens, Mount Sicily, Mount Vesuvius, Mount Etna. Volcanic active mountains: Mount Kilimanjaro in Africa, in Tanzania in Africa, and Mount Fujiyama in Japan, Mount Helena, and Pinatubo, Philippines, Mount Kia, Mount Loa in Hawaii. I have to write all these names, chances of forgetting the names. The mountainous crust. So these are the volcanic active mountains, These are the normal fold mountains with the volcanic active mountains. The mountainous crust or the mountainous crust are the weakest of the crust. Okay. Weak crustal parts, hence they fold up. They will have volcanic activity. The magma will be acidic lighter. Now continental convergence. Moving divergence is an oceanic divergence. Not even there cannot be continental oceanic divergence, not possible. And in convergence we have oceanic continental convergence and continental convergence. Continental convergence, there will be no volcanic mountains in this, because it's just a conversion of two continental plates. There is no subduction going on. So there is no subduction going on, just the convergence of the two continental plates. It leads to the formation of the fold mountain, but that is not an active mountain. No volcanoes will not be coming on. Just is a pressure applied between two continental plates, and that leads to warping and the folding of the landform. So continental convergence, fold mountain cages. So convergence. Now this oceanic plate is gone, of course. Now continental convergence. So same thing is happening, right? So first this was the oceanic plate is gone. Island is formed or mountain is formed, right? Then continent is left, and continent here we can have fold mountain, right? Sediments of, that's why here sediments of ocean plate is found. Okay, तो first there will be oceanic continental convergence हो गया, island form हो गया, या तो सॉरी oceanic continental convergence में fold mountain active fold mountain formed हो गया, ओशन गया, फोल्ड माउंटेन रह गया, फोल्ड माउंटेन रह गया। अब दो कॉन्टिनेंटल क्रस्ट और फोल्ड माउंटेन का जो कॉन्टिनेंटल क्रस्ट है वो दोनों कन्वर्ज करेगा एंड इट विल लीड टू द फॉर्मेशन ऑफ fold mountains, but that is which is not active like the Mount Everest, and that's why in such type of fold mountains we find marine deposits of the oceanic plate that was earlier that had earlier subducted. My goodness, so nice to read all this stuff. Okay, fold mountains created, subduction comes to an end, marine sediments and wilting after compression they will fold further and form ranges. Now continental convergence leads to the rise of marine deposits. Okay, so this marine deposit will rise when pressure is applied and will lead to the formation of fold mountain. So continental convergence leads to the rise of the marine deposits collected over the subducted oceanic plates. Already existing fold mountains in older continental plates, new folds created over the compressing plate. New folds created over the compressing plate, no subducting plate, no active volcanic eruption, no new acidic magma, no new eruption. Oh my god, I'm so tired. But I have to finish our goal today. Moving towards volcanically active fold mountains are formed on the margin of the continent, because of course at the margin of the continent only we will get the convergence of the oceanic plate, oceanic crust and continental crust, while fold mountains formed due to compression of two continental plates are located inside the continent. So this is a very interesting observation, because there is no subduction, no volcanic activities going on. Evidence of past volcanic will be there, but no present volcanic activity. Yes. So triangle in plate boundaries, and so triangle in plate boundaries means that the plate is converging. Acha. So triangle in plate boundaries means that the plate is converging. Andaman and Nicobar Island has oceanic convergence. Andaman and Nicobar Island. Okay. Example, Barren Island. Formation of Barren Island, that is an active volcano. So Andaman Nicobar Island, oceanic convergence, of course, that is an active volcano island. And then we have oceanic corresponding, then there will be active volcano, yeah, actively erupted fold mountain. We have seen Mount Helena, Mount Sisley, Mount Etna, and yeah, Mount Fukuyama is also there. So Barren Island active volcano, Narcondrum, Saddle Peaks Himalayas. So in the Saddle Peaks that is present in Himalaya, that is formed due to continental convergence. So examples are one of the most important thing to remember. Barren Island, Saddle Peaks. Okay. Russia Ural Mountain is a continental convergence mountain. Ural is a mountain, is not volcanic active mountain. This has formed the joining of the two continents. Continental fold mountains join the continental blocks, while rifts separate the two continental blocks again. This is a very interesting one. So when there is a continental interaction between the two continental crust and continental crust, it will lead to the formation of the fold mountain due to convergence. But due to divergence of two plates, oceanic plate, two different oceanic plate or the continental plate, it will lead to the formation of block mountain. But yeah, the rift separates two continental blocks away. So block mountain fold separating the continent. So block mountains, fold mountains. So block mountain will separate the continent and fold mountain will join the continent. Yes. Now moving towards oceanic convergence. Example from New Zealand to Andaman Nicobar, Barren Island. Oceanic continent. So now he has come up with examples. Oxford. Okay, we have to look at the Oxford map now. So oceanic convergence from New Zealand to Andaman. Oceanic continental, example Atlas Mountain, anti-Atlas Mountain on the margin of the continent, Alpine mountains in Europe. Oceanic from in the Pacific region. All the example in the Pacific and Andaman Nicobar Island. And oceanic continental we have like Mount Helena, Mount Etna, Mount Kilimanjaro. Oceanic continental, Atlas Mountain, anti-Atlas Mountain, Alpine mountains on the margin of the continent. So, Alpine mountain, many peaks in the Mediterranean region like Mount Sicily, Mount Etna, Mount Vesuvius, Mount Stromboli, all are volcanically active peaks. Okay. Now continental convergence, of course we have the Mount Everest, Himalayan to Hindu Kush, Altai Shan, Tian Shan. From this we understand that the formation of the mountain, from this we understand the formation of mountain, those process is called orogeny. So the process of the formation of the mountains are orogeny or orography also. Orogeny is not a continuously happening process but happens intermittently in episodes. In whole of the geological past, total 9 orogenic has happened. Oh my god, only 9. Of which last year important was like Caledonia orogeny. So what is orogeny? Is the formation of the mountain, right? Orogeny is the process of the formation of the mountain. It's not a continuously happening process but happens intermittently in episode. In whole of the total 9 orogeny event has occurred. Caledonian orogeny, all the mountains formed up to, okay, yeah, this I have done. Caledonian orogeny, so all the mountains formed up to 600 million years before present are known as Precambrian. So the mountains that has been formed before 600 million before present were Precambrian. After Precambrian we have Caledonian, that is 320 million years. So first is the 600 million years, then 320 million years. So Precambrian, Caledonian, before present mountains such as, and then we have the Scavendian mountains recently formed. Scavendian mountains are North Europe, Denmark, Norway, Sweden, Jutland Peninsula, Denmark. Okay. Then we have Hercynian period, Hercynian orogeny from 240 million years. So let's revise the time period. Okay. So Precambrian 600 million years. 6 3 2 याद रखना. So Precambrian 620 million years. Caledonian 320 million years. Scandinavian 240 million years. That is also known as Hercynian orogeny. Okay. So which mountains are called the Hercynian orogeny? It is from 240, from 632. 632. Okay. Hercynian orogeny 240 million years people. So mountains formed in these are Ural Mountain, Pennines, Wells Highlands, Ural Mountain, Pennines, Wells Highland, Haro Mountain, Appalachian, East North America, Siberian Peninsula, Mongolian Peninsula, Pole Mountain. And third is the Alpine orogeny, youngest. So Alpine orogeny they are the youngest mountains that are formed, and they're still forming like the Himalayas. So our Himalayas, our Mount Everest, it comes under Alpine orogeny. So alpine engineering, youngest industrial forming, Andes, Rocky. So Andes, okay, Rocky, North America, Himalayas, Alps, Atlas, uh, Paguyoma, Arakan Paguyoma and Arakan Yoma. Now we have the Block Mountain, that also comes in the alpine origin. That is Rhine River, Block Mountain, Black Forest, East African Rift Valley, Vosges. So Vosges is a Block Mountain, Black Forest, and Rhine River. Now we have transform boundaries. Now what happened when two plates they just uh, transform against each other, rub against each other, then it forms transform boundaries. So no convergence is happening, no divergence is happening. Just two plates are running, rubbing to each other in an opposite direction. Opposite force is applied here. So how many types of transform boundaries are there? Okay, I need a break. Andes, Rocky, Himalayas, Alps, Atlas, Teguyama, Arakan, Block Mountains, Rhine River, Black Forest, Vosges, Rhine River in France, Black Forest in Germany. Transform boundaries, continental transformation when the place slide past each other. So what are the some of the example? Like San Andreas, North America. We have San Andreas, North America. Child and New Zealand. Death Valley also transform. Death Valley is also created due to transformation of the continental plates. So we have San Andreas, North America, San Andreas and Death Valley. Moving towards transforming the ocean, transforming the continent. Examples. So example San Andreas and Death Valley. Yes. Transforming the ocean mainly happens in the mid-oceanic ridges. Okay, where the plates move away from each other or diverge, wherein oceanic ridges are formed mid-Atlantic ridges. So it's like one plate is moving away and then they meet somewhere and they transform between each other. Slide between each other. So along the vertical there are many offset horizontal lines. Okay, so mainly happens in the mid-oceanic ridges when oceanic ridges or mid-Atlantic ridges are formed. Along the vertical there are many offset horizontal lines and the oceanic ridges offset along the similar for the creating natural transform faults. Okay. Interplate tectonic activity. So these are the interplate tectonic transform, oceanic plate transform, mid-oceanic ridges, mid-oceanic Atlantic range, mid-Atlantic ridges. Okay. So due to transform ridges are formed, right? Yes. So along the vertical there are many offset. Similar for the plated child. Interplate tectonic activities. So all this process of convergence, mathematics and interplate tectonic. So what about the intraplate tectonic activity? Like mantle plume activity and hotspot region. There is no involvement of convergent plates. So no major explanation for intraplate tectonic activity. So mantle plume activity and hotspot region. So when they say that whenever the continents were moving, they came in contact with the hotspot region, and that's where the volcanic eruption took place in that continent. So when that continent moved away from the hotspot region, the volcanic eruption was over, but the evidence of volcanism remained, like the formation of the mountains, cold mountains, right? So mantle plume activity, hotspot, no oceanic, no contact, no major explanation, no ocean continental divergence. Okay. So lighter magma, denser magma, lighter magma rise up, silica, acidic is not basaltic, right? Hotspot at the oceanic crust. The magma is neither acidic, so in this there is no such concept of acidic lighter magma or the heavier magma. In this magma is neither acidic nor basic to form oceanic crust or island. basic. It will lead to shield volcanoes. So they will form shield volcanoes. It will rise above the water and form seal type of island. It will have volcanic peaks. It will relatively have higher basalt. Very समझ लो. The volcanic peaks might not be explosive. So these volcanic peaks, they might not be that explosive. So the volcanic peaks might be explosive or might not be explosive. For example, the Hawaiian island. Island chains are formed. So in this type of intraplate tectonic activity, island chains are formed. The magma is neither lighter nor heavier. The magma is neither acidic nor basic, not lighter nor acidic nor basic. It will lead to the formation of shield volcanoes. It will rise above the water and form shield type mountains, volcanic peaks, shield type of island, and it will have volcanic peaks. It will have relatively high basalt. So basaltic means flow horizontally. The volcanic peaks might not be as explosive. Example, Mount Japanese volcano, Hawaiian island. Island chains are formed as one island move other side due to atmospheric convection. Okay, the formation of island chains, because island keeps on moving from one way to the other. Island chains are formed as one island moves other side due to atmospheric convection. Volcano remains active. It creates other island. Again, the island moves the other side and leading to continuing of the process. It keeps on creating island chains. Such island might have seamount chain called the Emperor Seamount Chain Island, Hawaiian island. For example, Hawaiian Galapagos Island, and Iceland, Azores, Reunion Islands, right? So where is this spot is under the continental crust, geysers and hot spring. The Eurasian plate in Africa. Lava will continue to come reunion forming. Spread of basaltic magma in the Indian Peninsula. So like the central India region. When the Indian Peninsula was moving over the reunion hotspot, it led to the eruption of basaltic. So when this Indian Peninsula was moving over the reunion hotspot, it led to the eruption of the basaltic magma over the peninsular region. This magma spread, covering nearly 5 lakh square kilometer, the present size of 32.8 lakh square kilometer. It led to the formation of basaltic plateau. It is called as a Deccan Plateau, Deccan region, Deccan basaltic plateau. So what was the issue? So when the Indian Peninsula was moving over the reunion hotspot, it came in contact with the volcanic magma, volcanic eruption of the reunion hotspot. It led to the eruption of basaltic magma over the peninsular region. This magma spread, covering nearly 5 lakh square kilometer, the present size of 32.8 lakh square kilometer. It led to the formation of basaltic plateau. This led to the formation of basaltic plateau. So, Deccan basaltic plateau, Deccan region. When the Indian plate moved beyond the reunion hotspot, the magma eruption came to an end over the Indian Peninsula. No more basaltic lakes. No more basaltic lakes on the Indian Peninsula. Okay. Lava on the Indian Peninsula. Presently, Reunion Island is the latest formation of the Reunion hotspot. So there is a hotspot going on there under the continental crust. The creation of the chains of the island due to hotspot, and the formation of India's Deccan Peninsula. Done. Yes. Done. Deep focus across every of the mind, not in this right now. Now moving towards tsunami and volcano. Tsunami and volcano. How many pages are there? Warning system, types of volcanoes. Okay, chemical vapouring, rapid movement, global process, youth erosion, natural. So this is a flavor, no? So let's start. So tsunami and volcanoes. So tsunami, what do you mean by tsunami? So these are generally harbor waves, okay? This word is a misnomer. This is a Japanese term. Yeah. The Japanese are not harbor wave because they are generally in deep oceans and they travel towards the harbor. They are generally in deep ocean and they travel towards the harbor. So the tsunami is a Japanese term. So this is a misnomer, and they are called harbor waves. Reason? Deep ocean. They are there in deep ocean. Tsunami are generated in deep ocean and travel towards the harbor. Okay, that's why they are known as harbor waves. It's a possible cause of tsunami include what is the reason for tsunami? Earthquakes in the oceans, oceanic crust, the movement of the oceanic crust, and the continental crust as well. The possible cause of tsunami include earthquakes, that is tsunamogenic earthquake, landslide, that is flood landslide, volcanoes in the ocean, volcanic eruptions in the ocean. It all led to violent movement on the ocean floor and hence causing tsunami. Generally, earthquakes of magnitude 6.5 nautical miles and higher causes. So, what is the magnitude of earthquake? 6.5 magnitude. कितना होना चाहिए? 6.5. Okay. Harbor waves travel towards the harbor. I know. Deep oceans. Okay. Possible causes of tsunami, volcanic eruption in the oceans, earthquake, tsunamogenic earthquake, landslide, volcanoes in the oceans. It all led to violent movement on the ocean floor. So it all led to a violent movement on the ocean floor and hence causing tsunami. Generally, earthquakes of magnitude 6.5 magnitude and higher causes tsunami. Done. So in deep ocean, the characteristics of tsunami. Okay, very high velocity, was at the speed. Okay, high wavelength. Okay, high wavelength. I mean travels at a faster speed. Very high velocity, high wavelength. Low amplitude because depth of the ocean's rise of the water is less. Because depth of the ocean is more and rise of the water is less, so it has low amplitude. It doesn't have high amplitude, it's low amplitude. So in deep ocean, the characters are high wavelength, high velocity, low amplitude. Because depth of the oceans is more. Why low? Why it has low amplitude? Because depth of the oceans is more, and rise of the water is less. The wave does not carry the water. Now this is a very interesting point. We always think that whenever tsunami happens, then the wave carries the water, but the wave does not carry the water. Just a force. The water just goes up and down. It leads to the rising of the water, but it does not carry the water. So the waves does not carry the water just go up and down. Only wave energy propagates in the deep ocean. So just the wave energy propagates. It does not lead to the carrying of the water. It is not easy to send tsunami waves. Why? Because the amplitude is less, the wavelength is large, hence it takes too much time for the water to move up and down. The movement is also very less. So why it is not easy to send tsunami waves? Reason being the amplitude is less, wavelength is very large. So the amplitude is less, wavelength is very large, hence it takes too much time for the water to move up and down, and that's why we cannot sense it. It does not happen rapidly, and there is not so much action in the water that we will sense tsunami waves. Wavelength high, amplitude less, hence it takes too much time for the water to move up and down. The movement is also very less. So when the tsunami comes to the coast, then only we can understand the tsunami. Continental shelf not be kinetic energy turns into potential energy. So what happens when the tsunami comes to harbor or the coast? Here the kinetic energy will turn into potential energy. So when the tsunami comes to the coast, the wavelength starts decreasing and the amplitude starts increasing. मतलब rise ज़्यादा होने लगेगा. Initially the amplitude is low, there is low rise in the waves, but when they start coming to the coast, the amplitude increases and the wavelength will decrease. So initially the wavelength was more when the tsunami just started in the middle of the ocean, and the amplitude was less, which means height was less, but as they reach the coast, the wavelength stops. Reason being, the coast acts as a barrier, it acts as a force to stop the tsunami waves, but as it hit the coast, the height increases and the amplitude increases and the water rises. The rising of the water will be high. More friction, less depth, yes. So there will be more friction, less depth. Tsunami generally comes in more than one waves. Okay. Tsunami has crest and trough. ये पता है. Trough part of the tsunami, water will recede. Crest part, water will rise. Trough and crest. Trough part. So trough part of the tsunami, water will recede, and crest, of course. Crest part, water will rise. Crest and trough. Tsunami generally arrives in waves. Second, high waves of the tsunami can have high level of destruction associated, as people are generally unaware of the second wave coming. If the region which is close to the beach has gone up, you might have high wave. That is a crested form. So if the region which is close to the beach, if the region has gone up, right? Like you cannot see water, for from far distance, water is not visible. Ocean is not visible, which means tsunami is coming. You have to run away for your life. So if the region which is close to the beach has gone up, you might have high wave. That is a crest. If the region which has gone down, you may have trough. That is a low wave. So it's a very interesting point. In the region which is close to the beach has gone up, crest and trough. On the coast, if the water is receding, this is also a sign. So water is going back. post, "Hi Farah, I'll reply after half an hour." So it's a live study session going on. Um, so on the coast of the water is receding, that is also a sign of tsunami, and hence people should be made aware that if the water is receding, they should go away from the ocean. Tribals know this phenomena very well, and for example, Andaman Nicobar Island is an example. When the tsunami happened in 2004, there was no loss of life among the tribal. So they have this knowledge. We common people, we don't have such knowledge. What is crest, what is straw, when the water is receding, then we have to move back, not go front and look at the oceans, why all such phenomena are happening. So these are things. Where do we have a possibility of tsunami-genic activities? So in the Ring of Fire zone, where volcanic activity is happening in the Pacific Ocean, that is the Ring of the Fire zone, Indian Ocean region, where we have major subduction zones. This is a region where the plates, oceanic plates, they're converging and subducting, and this zone is active, and that's why it has tsunami, because of frequent volcanic activity going on in this coast in the Pacific region. Tectonically active tsunami-genic regions: Makran Coast, the Makran Coast, Arabian Sea region. In September 2000, National Disaster Management Authority did the tsunami drill, assuming a tsunami generated at the two locations, the east coast and the west coast. So the region Pacific Ocean, Makran Coast, trenches region, Makran Coast. Tsunami warning system. After 2004, the tsunami warning, Indian Ocean tsunami early warning system has been developed so as to sense any tsunami generated in the Indian Ocean. This information is also shared with the Australians, New Zealand authorities along some Eastern Africa regions, Alaska and the Pacific tsunami early warning systems. Moving towards the Hawaiian island. The Hawaiian Islands are especially more vulnerable to destructive tsunami generated by the major earthquake in the Pacific Ring of Fire. So Hawaiian Island in the Pacific, more volcanic activity, so more prone to tsunami. Now we are moving towards tsunamis terminating volcanoes, left portion of the volcanoes. So now what are the different types of volcanoes? So recently what I have learned about, that was about magma, right? Lighter magma and the heavier magma, more silica content, less silica content, acidic, basaltic. So types of the magma depends on the classification of the magma, where they are found, and on the basis of activity. So where they are found: intrusive, that is plutonic zone, and extrusive zone, that is basaltic. Intrusive. So where they are found in intrusive and extrusive volcanoes. Other one is on the basis of activity: action volcano, dormant volcano, and active volcanoes. So intrusive, of course, is a forming site. So first there's this action volcano, that is that has not, that the volcano that did not erupt in known history. Dormant volcano is known to have erupted and has a possibility of erupting again. So action volcano that has not erupted in the known history. Dormant volcano, there is a history of eruption and can erupt anytime in future. Active volcano, when it is frequent, it is erupting frequently and have erupted in the recent part. Hawaiian Island, the barren island of Andaman and Nicobar, examples. The material which is igneous tells us about the volcano. Okay, however, the definition is not clear one, because an extreme volcano might become active at any time. We don't know. So on the basis of magma, there are 6 types of volcanoes. We have the extrusive volcano, intrusive volcano, horizontal, vertical, different types of volcano. Hi Deepak, I'll be replying after 4 minutes. Okay, so stay. So extrusive above the ground, also known as lava, and intrusive inside the ground, known as magma. So the difference is there in the names that we use. Extrusive is known as lava, and intrusive is known as magma. So intrusive features is classified on the basis of arrangement. So it's a very interesting point. On the basis of activity we have done, now we are doing on the basis of where they are found, intrusive or extrusive. So intrusive is more important. Extrusive, we know they are known as lava because they have already erupted, and in extrusive is above the ground and it has already erupted, and intrusive is the magma, which will be erupted, and it can be vertically and horizontally arranged. So let's see how we arrange it vertically and horizontally. So intrusive features is classified on the basis of the arrangements: horizontal and vertical. Horizontal between 2 layers, they are flat intrusions. Simple horizontal sill, example is very important, like sill magma, horizontal between 2 layers. So they are arranged between 2 layers. They are flat intrusions. So horizontal arranged between 2 layers, they are flat intrusions. Simple horizontal is sill, and then we have the vertical, cutting through the layers and to rise up. So I think vertical will be the magma that is lighter, and horizontal will be the magma that is heavier. Yeah. So horizontal between 2 layers, simple horizontal is sill, and vertical cutting through the layers to rise up, that is dike. So sill and dike. Logic is the most important. Now we have the complex horizontal and complex vertical. Let's see how we'll be doing this. How many pages more? Just getting done today. Oh my god, I just finished this chapter. Amazing. So okay, now let's look at complex horizontal. This primarily related to heavier magma, that forms horizontally inside the continental crust or the ocean crust. So complex horizontal, it has anticline and syncline. Anticline the upward part, and the syncline the downward part. Anticline and syncline, anticline the upward part. So first I will do all the horizontal, then I will be doing all the vertical. So horizontal: pacholith, lapolith, lacolith, batholith. Paco, laco, batho. Okay. So pacholith, it's a complex horizontal volcanoes. Characteristic they form are anticline, syncline. Pacholith is convex surface. Okay. Convex surface formation that can be anticline and syncline. So pacholith is a horizontal volcano. They form anticline and syncline. Pacholith is a convex surface formation, right? And then we go anticline. Lapolith is a saucer shape formation, like this, forming a basin, that is saucer shape. So pacholith, anticline, syncline, saucer. Lacolith like this. So one is like this, like mountain. This. This is Lapolith. Lapolith is like saucer shape. Lapolith is like quark. Is a dome-shaped surface with a supply pipe conduct for magma. So it has a supply pipe. So it's very active. Okay, break. I didn't see. Break. complex horizontal characteristics, they form an anticline and syncline. Then we have tacholith is a convex surface, that can be anticline. Tacholith convex of the anticline, syncline, convex. Locolith is saucer shaped. Laccolith dome shaped with a supply. So laccolith is a supply pipe cut across for magma. And batholith is very large horizontal igneous formation. Granules or the denser magma. Yeah. So very large horizontal igneous. सबसे denser कौन है? Batholith. So it's a batholith is a denser magma, very large horizontal igneous formation. It can extend up to 100 km. When exposed, the batholith are generally called as shears. Highly resistant rock, do not erode fast. For example, Canadian shield and Siberian shield. So these are the intrusive horizontal magma. So we have if arranged in a horizontal way, then we have tacholith, that is the convex shaped anticline. Locolith, that is the saucer shaped. And then we have the laccolith, that is a dome shaped. And then we have the laccolith, that is a dome shaped surface with a supply pipe conduit for magma. Then we have batholith is very large horizontal igneous formation. Batholith, laccolith, locolith, done. So complex horizontal is done. Now moving towards complex vertical, that cuts to each other, dike. So this example is cell, yes, cell. Different types of example is dike. So complex vertical, dike or neck. The dike less resistance. Okay. So these are the lighter magma, we can say, or because they are formed vertically, one above the other. Dike or neck of the volcano, dike less resistant than nearby rocks. If the rock is not resistant, it might create a depression, in which lakes can be crafted. Extrusive volcano formation. Extrusive volcano, also known as lava, are classified on the base of the magma from which they are formed. The most basic of this formation is the fissure volcano. Extrusive is a fissure volcano, also called as the flood basaltic volcano. Classified on the basis of magma from which they are formed. Of the magma for which they are formed. The most basic of this formation is the fissure volcano, also called as the flood basaltic volcano. This might cover a very huge area. For example, Deccan lava plateau. So the fissure volcano horizontally spread extrusive most basic fissure volcano. Just remember fissure volcanoes, and also called as a flood basaltic volcano. This might cover a very huge area. Example, Deccan volcano. Still, volcano is the second large formation, which is generally formed from mantle plains. Social volcano is the second large formation, which is generally formed from the mantle plume, for example, the Hawaiian island. So we have the extrusive volcano, it is a fissure volcano. The shield volcano is the second largest formation in the extrusive volcano. Hawaiian island relatively less extrusive volcano. So now we have done the intrusive volcano arranged vertically and horizontally. Horizontally, we have different shapes like anticline, syncline, saucer, that is the locolith. Laccolith is like a dome. dome-shaped surface with a supply pipe, and a battery that is very large horizontal igneous formation. It can extend to up to 100 kilometers. When exposed, the battery are generally called as shields. So when exposed, the battery are generally called as shields. Highly resistant rock do not erode fast. For example, Canadian shield and Siberian shield. Complex vertex, that is a dike, or the neck of the volcano dike is less resistant than nearby rocks. If the rock is not resistant, it might create a depression into the legs of it. That is a complex vertical. Extrusive volcano formed outside the crust, classified on the base of the magma forms. They are formed. The most basic of this is formation is a fissure volcano, also called as a flood basaltic volcano. This might cover a very huge area. For example, Deccan lava plateau. Shield volcano is a second large formation. This type of volcano is the ash and cinder volcano, ash and cinder, okay, which form in multiple numbers generally, and do not have too much height. So there's a heavier volcano, that's right. Denser volcano, not heavier, denser. They're generally steep in mature with height. They're generally steep in mature with height not more than 300 to 400 meters. Fourth type is the composite volcano. Third type of the volcano, cinder volcano, composite. Okay, we are talking about the extrusive volcano first. Fissure volcano, composite volcano, cinder volcano. This type of volcano, it is the fissure volcano, right? This type of volcano is the ash and cinder volcano, which form in multiple numbers generally and do not have too much height. So they can be considered denser areas. They are generally steep in and they are generally steep in nature with height not more than 300 to 400 meters. Then the fourth type is the composite volcanoes. Fourth type is a composite volcano, which are the largest volcanic formation. They mostly have very high heights, yeah. So this is formed due to lighter magma. So they mostly have very high heights and also have parasitic cones, yeah, that gets blasted. Have parasitic cones, parallel vents from which the magma leaks on the side. So composite volcano, they have very high heights formed due to the eruption of the lighter magma. They also have parasitic cones or the parallel vents from which the magma leaks on the side. Their nakes are also called as parasitic cones. Make, for example, Mount Etna, Mount Stromboli. So it's Mount Etna, Mount Stromboli. So they have parasitic cones. And Mount Vesuvius, they eat some part of the magma that should have gone into the main belt. So Mount Etna, Mount Stromboli, Mount Vesuvius, and Mount Sicily. Mount Fujiyama, Mount Chimborazo in Andes mountain. So Mount Chimborazo in type is caldera type of volcano. Fifth type is caldera type of volcano, in which top part has generally blown away. So fifth is a caldera type of volcano in which the top part is generally blown away. These are the most explosive volcanoes of the lightest, like Mount St. Helena. So we have different types of explosive volcano. There is a fissure volcano, composite volcano, and caldera. Composite caldera lighter, cinder थोड़ा heavier side, and fissure heavier side. Mount Fujiyama, Mount Chimborazo, and fifth type is the caldera type of volcano in which top part has generally blown away. These are the most explosive volcanoes, like the Mount Helena. The exogenic geomorphic process and associated landforms. So now exogenic process intergenetic between sun is a major source for most of the exogenic forces. The agent and the force can be interchangeably used, like the fluvial force, running water force, eluent force, fluvial force, running water force, eluent force, blowing air force, glacial force, the force. Okay. I'm going to into the different types of forces. Fluvial, meandering, delta, vivid stream. Okay. So the volcanic part is done. I'm just making small notes of this all parts, whatever I have read. Pangea, Panplaza, northward, southward, Laurasia, Gondwana land, Tethys. Okay, just make a small notes and write small words so that we remember it. cross, igneous rock, okay, earth crust, igneous metamorphic, the influence of rock tectonic, volcanism, weathering landform volcanism. Weathering landforms, perennial landforms, okay. Lakes, coastal landforms, island, oceans. So volcanism and earthquakes. Landforms associated with volcanic activities. So we have already discussed the oceanic, continental related to the formation of whole mountain. It will be active whole mountain. Continental convergence related to the formation of the whole mountain, but it won't be active. It will have the evidence of some type of marine deposits. Then we have the continental convergence that leads to the formation of island, and then we have intramantle plume activity, the hotspot regions, that leads to the formation of hotspot regions that lead to the formation of chains of island like the Hawaiian Island and the Reunion Island. Okay, so let's see. Volcanic activities have a profound influence on the Earth's landforms. Solid, liquid, or gaseous materials may find their way to the surface from some deep situ reservoir beneath. Molten magma is mobile. Molten magma is nothing is mobile rock that forces its way into the planes of weakness of the crust to escape quietly or explosively to the surface. The resultant landforms depend on the strength and fluidity of the magma. So the resultant landforms depend on the strength and fluidity of the magma. This type of cracks, faults, and joint that it penetrates, and the manner in which it escapes to the surface. Magma, while thrusting its way to the surface, may cool and solidify and form landforms beneath the crust as plutonic rocks, resulting in intrusive landforms. Okay, intrusive landforms, plutonic rocks. Intrusive, we saw the horizontal magma and the vertical magma, right? Horizontal magma we saw Napolate and all. Lapolate, locolate, lapolate. So intrusive landforms, vertical, horizontal. Magma that reach the phase and solidify forms extrusive landforms. Okay, that is sill, composite volcanoes and all. Dike. This is dike. Parasitic landforms and all. Okay. Magma that reaches the surface and solidify from extrusive landforms. Magma while which it escapes the surface. Magma while thrusting its way to the surface may cool and solidify within the process plutonic rocks, resulting in intrusive landforms. Rocks formed by either plutonic or volcanic activity are called igneous rocks. Either plutonic or volcanic activity are called igneous rocks, landforms of igneous intrusions. So what are the landforms? What are the landforms of igneous? So landforms of igneous intrusions, perhaps the commonest intrusive landforms are intrusive, right? Is sills and dikes. Dikes and sills. Let me see. Perhaps the commonest intrusive landforms are cells and dikes. Intrusive, right? So dikes, there and cells. Yeah. When an intrusion of molten magma is made horizontally, Ronnie, I will be replying after half an hour. It's already 8 minutes is left. So let me complete it. So when an intrusion of molten magma is made horizontally along the bedding planes of sedimentary rocks. So when an intrusion of the molten magma is made horizontally along the bedding planes of So perhaps the commonest intrusive landforms are sills and dikes. When an intrusion of molten magma is made horizontally along the bedding planes of the sedimentary rock, the resultant intrusion is called a sill. Landforms of igneous intrusions. So the commonest intrusive under the landform are sills and dikes that we have learned about intrusive volcanoes, right? Intrusive horizontally. When an intrusion of the molten magma is made horizontally along the bedding planes of the sedimentary rocks, the resultant intrusion is called sills. Horizontal color, right? We saw. Yes. Denudation of the overlying sedimentary strata. So denudation of the overlying sedimentary strata will expose the intrusions. Will expose the intrusions which will resemble a lava flow or from a bold escarpment like the Great Wind Sail of inland. Similar intrusions when injected vertically as narrow walls of the igneous rock within the sedimentary are termed as dikes. So there is an issue, I think. What is the topic about? Landforms of igneous intrusions. Lopolith, Pacholith. So Lopolith, Pacholith we did. That was anticlinus and convex, right? Yes, anticlinus. Lopolith, Pacholith. Batholith we did. Origin of the volcanoes. So origin, plate convergence, Mount Mew, Philippines eruption. Not too much. Mount Pele, earthquakes, so is there all earthquakes, and we have weathering mass movement in groundwater. Perhaps the commonest intrusive landforms are sills and dikes. When an intrusion of the molten magma is made horizontally along the bedding planes of the sedimentary rocks, the resultant intrusion is called a sill. Denudation of the overlying sedimentary strata will expose the intrusion which will resemble a lava flow or form bold escarpment like the Great Wind Sail inland. Similar intrusions when injected vertically as narrow walls of igneous rocks within the sedimentary layers are termed as dikes. Sills and dikes. So we have seen already dikes and sills. Horizontal sides and axes. Because of their narrowness, dikes seldom dominate the landscape. Why the dikes is forming? Because of the narrowness. So because of the narrowness, dikes seldom dominate the landscape. When exposed to inundation, they may appear as upstanding walls or shallow trenches. Depending on whether they are more or less resistant than the rocks in these areas. Example of dikes are Clevent Dyke of Yorkshire, England, and hundreds of others in Isles of Man, Arran in Scotland. A large, very resistant dike of quartzite forms a long ridge to the north of the Kuala Lumpur. Igneous intrusions on a larger scale are the various types. Now we have done this. Pacholiths, lopoliths. So talking about pacholiths, that's a convex shape, has anticline and syncline. Then talking about the lopoliths, so it's a saucer shape, right? And batholith is a large stretch of horizontal magma. It's very formed due to denser magma material. So one we have the convex shape, then we have the saucer shape, then we have the batholith. So lopolith is another variety of igneous intrusions with a saucer shaped. A shallow basin is formed, and so if we talk about lopolith, so it's a saucer shape, right? A shallow basin is formed in the midst of the country rocks. The Woodsville lopoliths of transverse examples. The Woodsville lopoliths of transversal South Africa are good examples. So this is an example of saucer shaped horizontal magma. Then we have the pacholiths with anticlines in a convex set. So it's a lens shaped mass that is a convex set of igneous of occupying the crust of an anticline or the bottom of it as a syncline and being fed by a conduit from beneath. But they said pacholith is fed by a conduit. Okay, let's move it on. An example of pacholith is the Condon Hill in England. So Condon Hill in England and lopolith, Woodsville lopoliths. Okay. For examples, batholith is a large, huge mass of igneous rock, usually granite, which after the removal of the overlying rocks forms a massive and resident upland region such as of the Wicklow Mountains of Ireland, the upland of Brittany, France, and the main range of west of Malaysia. The precise mode of origin is still a matter of controversy. It is only believed that large mass of magma rising upward metamorphosed the country rocks with which they came into contact. Okay. This metamorphosed rocks together with the solidified magma gives rise to the extensive batholiths, sometimes hundreds of the miles to extend. They are the most spectacular and intrusive landforms. So they're very important examples of this. We're moving towards the topic, the origins of volcanoes. So origins of volcanoes, difficult to trace. So we have the ancient philosophies on the origins of the volcanoes. Then we have basic lava, acidic lava, lighter, silica content and all, right? Now types of extrusive landforms and intrusive landforms. Extrusive landforms. Mount Vesuvius, Mount cracker 2. Okay, break. So guys, can we start with the test quiz? So I'll keep a half hour session for quiz. Okay, I'm just setting a timer of 30 minutes. Yeah, I'll start. Just let me set a timer. Just wait for 2 minutes. Questions. So every day for half an hour, uh, we'll do quiz. Okay, tell me if you are ready. Ghost. Ready? Guys, you're ready? Then I'll start the timer. Anyone can reply yes, ready, something like that. Let me just mute this. So, are you ready? Is my voice clear right now? Are you ready? Okay, let's start. So, in 1927, Simon Commission came to India, right? Why was it boycotted? What was the reason that Simon Commission was boycotted? So, what was the reason? Reddy? What Reddy? Okay, Reddy. So, I'm asking question. Okay, let me start the timer क्योंकि आधा घंटा ही करेंगे अभी डेली. So, Simon Commission 1927 में इंडिया आया था to promulgate constitution or what you can say law for the country, democratic law for the country, but it was boycotted by nationalists. Yes, it was boycotted by the nationalists. Why? I'm asking the reason. Why was it boycotted? Then I'll tell you the answer if nobody can give the answer. So the nationalists boycotted the Simon Commission. What was the reason for the boycott? No Indian. Yes, Rishabh, you're right. You're right. Yes, there was no Indian member in the Simon Commission, and they constituted Simon Commission to promulgate the law for the country in which there were no Indian members. Law for India in which there were no Indian members. Okay. So this is a little bit tough question, I would say. So during the Indian freedom struggle, so the Indian freedom struggle, who proposed that Swaraj should be defined as complete independence, free from all foreign control? Proposed. I'm saying who proposed. Do you want the options? Do you want options? So Mazharul Haq, Maulana Hazrat Muhani, Ajmal Khan, Abdul Kamal Azad. So who proposed that Swaraj should be something that is free from all the foreign control, defined as something that is complete independent. Ganga, what is Ganga? Bal Ganga, okay, Bal Ganga. No, 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 no. In my option, there was no Bal Gangadhar Tilak. I'm giving you the option again. Mazharul Haq, Maulana Hazrat Muhani, Abdul Kalam Azad, and Hakim Azmal Khan. The most common name. That's why I said it's a bit tough question because it's not the normal nationalist leaders who propose this. The general nationalist leaders whom we hear about every day. So it's Maulana Hazrat Mohani. So Hazrat Mohani was a famous freedom fighter. Okay. Did I ask this question? Where is the living roots found in India? In which state? Living roots. The concept of living roots. So in the Indian state where it is found, the living roots. Now I'll start typing the answer, just wait. Can anyone answer? Living roots, the concept of living roots. Yes, it's Meghalaya. So what is the concept that they tie the deep roots, of the trees, and they have made a bridge out of it. So this is known as sustainable living. Okay, so moving towards another question. Okay, what does the 7th schedule of the Indian Constitution contains? What does the 7th schedule of the Indian Constitution contains? Language. No, it's wrong. Not language. This is wrong. So I'm telling you the answer. The 7th schedule of the Indian Constitution, it divides the law-making power, the legislative power between the center and the state. So there are central list, state list, and concurrent list. Okay. So there are no residual lists. So don't confuse with the law-making, not administration. Law-making power, legislative power into central list. So the subjects that are there in the central list. The law-making power lies with the parliament. The subject that is there in the state list, the law-making power lies with the state legislature, and the concurrent list, both center and the state can make law on it, right? For example, education. Yes. Okay, now moving towards another question. Okay, recently you heard the news that the vice president has resigned. So how will the new VP will be elected? How the new vice president will be elected? So how will the this laptop is this? So this is a simple Dell ka laptop, not I, not Apple ka laptop. So how will the new VP will be elected? Voting. Everyone knows voting, but how? Who will vote? We are not going to vote. Then who is going to vote? In Rajya Sabha and Lok Sabha, yes. So it's both the elected and the nominated members of the Lok Sabha and Rajya Sabha. Not maybe, it's both the elected as well as the nominated members of the Lok Sabha and the Rajya Sabha. Okay, fine. Okay, now we are moving towards another question. So there is a provision in the Indian Constitution, that is the separation of the judiciary from the executive, so that there is autonomy, okay, so that they could work without any pressure and in a neutral way. So where it is written, so this provision, where it is written in the Constitution, fundamental rights, fundamental duties, or DPSP, in president only elected, yes, in president only elected, yes. So this is a difference, only elected members, yes, and even legislative assembly also, but in VP legislative assembly is not involved, legislative assemblies are not involved. Okay, so there is a provision in the Indian Constitution that says separate the executive from the judiciary. So where it is written, fundamental rights, DPSP, fundamental duties, or in federal concept, federal provisions, where it is written? Yeah, you're right, it's written in DPSP, yes. So can anyone tell me that right to property, is it a constitutional provision or a statutory provision or both? So right to property, or is it a natural right, or is it a fundamental right? Is it a constitutional provision, statutory provision, or a fundamental right? Statutory. So it's both constitutional as well as statutory, because the parliament has framed law also for the right to compensation to right to property. Compensation when you acquire someone's property, when the center acquires property, and even it is written in constitution as well, in article 300A, I think. So it's both a statutory and constitutional provision, but it's not a fundamental right. Okay, earlier it was fundamental right, but it has been revoked because of the socialist policies of the state, when land reform policy was implemented at that time. Okay, I'm asking some other type of question. So who published economic survey? So economic surveys India is published officially every year by whom? Okay, if nobody gives the answer, then I'll give the answer. IAS. No, 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 no. It's a ministry, of course. I didn't say the name of the ministry. It's published, so it's a ministry. No, no, not CAG. No, no. CAG is not involved at all, in publishing of the economic survey. It just audits the expenditure of the center and the state, the governments, and presents it. And even CAG doesn't present the report in the parliament. It gives to the president, and then the president presents the audit report in the parliament. Where it is reviewed by PAC, that is Public Account Committee, of the parliament. No, it's Ministry of Finance. I said Ministry of Finance. Yes, that's why I'm saying those जो लोग बहुत ज़्यादा दिमाग लगाते हैं उनके लिए तो okay, so so finance commission, the finance commission, it comes up with the report in terms of revenue distribution between the center and the state. Okay, so finance commission, it comes up with the report in terms of revenue distribution between the center and the state, so is it compulsory for the president to accept the recommendation of the finance commission, or is just advisory in nature? So is it compulsory to accept the report, or is just advisory? Just tell me the answer. Compulsory or advisory to accept the report? The president, for the president, is it compulsory or advisory? The president can or cannot accept the report, or it is compulsory for the president to accept recommendation of the finance commission? Advisory. Yes, you're right. So it's advisory. Nothing is compulsory in administration. Primarily if you're talking about the ministers. So I'll ask some other questions. So can you tell me what do you mean by balance of payment, BOP? BOP, balance of payment. President is Sigma. No, president is not Sigma. President has to act on the aid and advice of the Council of Ministers. So it's the Council of Minister, the Prime Minister who is the Sigma. President is just like a puppet. So what did I ask? Oh, BOP. No, it's not expenditure and revenue. No, 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 no. You're talking about fiscal responsibility and fiscal budget of the state. Is BOP, balance of payment. Is something related to foreign countries and all. Your trade and all. Mr. Dhankar, he is not a president, he was a VP. And you know, a vice president is primarily, if you see the constitution, their salary is given to the chairperson of the Rajya Sabha. There is no such salary mentioned for the vice president. You know, import export, yes. So balance of payment refers to the import and the export of a country. It can tell us if the country is suffering from trade deficit or trade surplus. Okay, it comprises the import and export of all the goods, services, capital assets, everything. Okay. And if we know BOP, then we also know how is the currency of a country doing. Okay. Okay, can anyone tell me what is the meaning of disguised unemployment? Disguised unemployment. Infield. 5 people doing work of 2. No, nothing like that. 5 people doing work of 2. So it's like people are doing part-time job, but still they are not. People are not doing productive job. Understood? They are doing part-time job, but still they are not counted in the unemployment statistics and how many youths are unemployed. So it is considered that they are doing job, although they are not doing productive job. Okay. So this is known as disguised unemployment, wherein they are not counted in unemployment statistics. Unemployed statistics. Okay. Five people doing work of 2 people. ये कैसे सही है? I don't. ठीक है, मैं देखूँगी बाद में. I'll do it. I'll say right now. Disguised unemployment is like when you're not counted in the unemployment statistic, even though you don't have good job. So I'll check. 5 people doing work of 2 people. Is it? Okay. Okay, Rishabh, it's fine. So, tell me that NABARD, does it give direct loans to the farmers? NABARD. So, NABARD, does it provides direct loans to the farmers? No, it doesn't give direct loans to the farmer. It's like a shadow bank. It gives money to the banks. Banks are under priority lending certificate. Priority lending policy. They give that money to farmers. Understood? Okay, fine, fine, Rishabh. I also trying to end it because I have to end the session now. It's already 3 hours. I have been studying for 3 hours. Okay, I'll start another session after some time because I have to study today. Oh, I have to study whole night. Okay. So I'll be starting another session in half an hour. It will be a 2-hour session. So bye, take care. So I will be starting another session in half an hour. Okay.